Hello team, today I'm going to present my project scope and dataset description of my project. The title for my project is Classification of Smokers, Non-Smokers and Drinkers, Non-Drinkers using Hybrid Electrocardiogram, ECG and Medical Data. I am Tiggs Balacho, and this presentation is for my assignment on UMGC Data Analytics Capstone project of spring semester 2025. My professor is Hani Saleh. In this presentation, the project scope, including problem description, background in research, and gaps in research, proposed project, stakeholders, business success criteria, key performance indicators, project insights, and dataset description, lesson learned to date, take next steps, and the reference will be discussed. The background of this problem is that according to the World Health Organization report, by the year 2027, there will be a threefold increase in cardiovascular deaths from when it was 1 million in 2019. There are different risk factors for this cardiovascular disease. Among them is smoking and drinking. In 2019, around 2.6 million deaths were registered due to alcohol consumption in this year. In addition, tobacco kills more than 8 million people each year. Most, even though cardiovascular disease is preventable, identification of smokers and drinkers is biased and mainly focused on self-reporting. This depends only on the willingness from the patient side. So the capability of electrocardiogram in identifying smoking and drinking habits was not used widely. In the research background side, the ECG is an important tool for monitoring heart health as it's used to treat or diagnose a wide range of cardiovascular problems. The study also showed that smoking and drinking can affect ECG patterns and cardiac functions. So combining the ECG parameters with patient demographic and medical information can be used to determine whether they are smokers or non-smokers or drinkers or non-drinkers. And this diagram shows the ECG parameter for a normal heartbeat. One heartbeat is just from here to here. So it's a graph of voltage as a vertical side, and the x-axis showing the time it takes for each patterns. These waves are obtained by attaching electrode to the skin of an individual, and the electrodes generate signals by converting vibrations that are caused by cardiac muscle depolarization and repolarization during each cardiac cycle. In this diagram, one bit is shown where the first positive upward deflection, that is this one, the green one, is called the P wave, which shows the atrial depolarization, and followed by the first down deflection called the Q wave, and the second upward deflection, the peak, the Q, the R wave, and then the second downward deflection, the S wave. And this is called the QRS complex. This shows the ventricular depolarization of the heart, and this followed by the T wave. This is a blue wave, is a T wave, which shows the electrical activity of the ventricles as they repolarize and prepare for the next contraction cycle, and this cycle will repeat itself. All these intervals, the PR interval, the QRS, and the ST segment, the QT interval, these all intervals and the peaks all are useful for detection of heart disease when they deviate from the normal range as indicated here. Like this is a normal ECG values for different intervals and waves. Like the RR interval, this is the first peak to the next another beat, the R to R. It indicates the heart rate. It should be 0.6 to 1.2 seconds. And these are the amount or the measurement parameters for each parameters. So different research studies were undertaken in this area that reveal the alcohol consumption and smoking alter the ECG parameters. Mata stated that smoking alters the heart rate variability, that is the R to R interval, and alcohol use alters the QT interval and heart rate dynamics. Raja also states that most common ECG changes are associated with acute alcohol consumption are P wave and QT prolongation, followed by the T wave abnormalities and QRS complexes. Regarding machine learning, application of machine learning for evaluating the ECG data for diagnosis, different health issues were studied. In addition, machine learning usefulness was also studied to predict smoking behaviors using ECG and other physiological data. The gaps in research area are most of the research focus on identifying cardiac illness or arrhythmias, and the studies are limited precisely analyzing ECG data to identify such behaviors. Using ECG data alone is useful. Numerous studies emphasize the need for combining multiple data sources to make more accurate lifestyle recommendations. So the existing databases either concentrate on medical records related to smoking or drinking, or on ECG parameters for cardiac disease, but not at the same time. So the proposed project will leverage machine learning algorithms. So utilizing these machine learning algorithms, this project will try to develop classification model that can accurately identify smokers, non-smokers, and drinkers, non-drinkers, based on the combination of features from ECG data and major medical records from individuals. This will provide an expanded understanding of the ways in which drinking and smoking affect cardiac health. The stakeholders of this project are mainly healthcare providers, such as physicians, clinicians, hospitals, which will benefit from the project. The other stakeholders are designers, which are responsible for continuously assessing the performance and improving it. And the cardiologists and other technicians are also stakeholders who are responsible for reading and interpreting the result of ECG as well as other medical results and validating them for the effectiveness of the models generated. The success criteria are aligning the model with the business objectives and selecting proper data set and loading into a suitable data structure, answering all the business questions developed, extracting meaningful features which will add more insights, and meeting all key performance indicators for the model developed, and meeting ethical consideration at all stages. There are 5 key performance indicators that will be used to measure the performance of the models, the predictive models. And the first is the area under the curve, that will be 0.8 to 0.9, and it will be able to distinguish between negative and positive classes. And the second is sensitivity, that will be greater than or equal to 0.8. Is a measure of proportion of actual positive cases, that smokers and drinkers, that the model correctly identifies. And here also the false negative rate will be less than 3%, that is the failing to identify someone as a non-smoker or non-drinker when they are, so to minimize misclassification or mistreatment, this will be set as less than 3%. And the specificity will be greater than or equal to 0.85. This aims to minimize the false positive to reduce unnecessary effort on patients, wrongly identified patients. And the F1 score will be between 0.85 to 0.90, which is a harmonic mean between specificity and sensitivity. And the last is accuracy, which will be greater than or equal to 0.8 or 80%. The product insight from the data analysis is a classification of smokers or non-smokers and drinkers and non-drinkers, which will in turn use to identify high-risk patients. And predictive models will perform better in terms of accuracy, AUC, precision, and F1 score. And the models will be generalizable across all forms of new ECG and medical data fed as a test set. So final recommendations for further study will be highlighted. The second part of this project is a dataset description. The first dataset, that's smoking and drinking dataset, is from the National Health Insurance Service in Korea, downloaded from Google. It contains around 991,346 observations with 24 columns. The second dataset is from electrocardiogram vigilance with electronic data warehouse database. It's a large single center database from IU University School of Medicine, Department of Biomedical Informatics in Republic of Korea. It contains 49,649 observations with 13 columns. This high-level data diagram indicates how the two big data sets are going to be used for this project. First, that these two data tables from the ECG dataset will be merged using the person ID. That's the key and is common to both of the tables. And the resulting data set will be merged with the smoking and drinking dataset using age and sex variables, after cleaning each dataset separately, because some variables like age, sex are not compatible with each other. The smoking and drinking data definition table is here, and it has 24 features in each data type, and description is indicated here. As you can see, there are object data types, integer data types, and almost most of them that are float data type. But some, like here left, here right, these are it should be object, and this should be converted to object in the cleaning data cleaning section. The ECG data definition is also indicated here. As you can see, we have two data tables in this big data set. The person data table has 4 variables, and the electrocardiogram data table has 13 columns, and all the data type is indicated here with a description. These are, as you can see in the heartbeat diagram before, you can see the RR intervals, the PR. These are all the ECG parameters. The QRAs, the QT, QTC, P wave axis, QRS axis, T wave axis, and the age adjusted, the ACCI, age adjusted Carlson comorbidity index when ECG was performed. The lesson I learned from these projects are here. The first is problem selection is a crucial step in this project, and dataset identification from different data sources with a specified requirement was challenging. So due to the lack of large dataset, project scope was updated on the second week based on my professor feedback. So using ECG signals, one can detect anomalies, and I learned the different techniques on how to extract ECG signals. This part of the learning is from the first, before the update, I learned from the first project. And I learned also that how to combine dataset with no common variable using other keys like age and sex. And due to the large dataset I have, I needed to update my version of Google Colab to have additional memory to process the large dataset I have. The next step will be data cleaning and pre-processing, and then the data visualization, and then data analysis, and the last is predictive models building, validating them, and testing them, and finally generate the recommendation from the findings. So here in my last slide, I provide all the reference that I used in the project. Now you are free to forward your questions and feedback on this project scope and dataset description part. Thank you for your precious time, and this concludes my presentation. I look forward to sharing my second presentation after data cleaning or pre-processing in data visualization in my presentation 2. Thank you again for your listening.